Okay, so I'm back to show you the Punnett Square in a little bit easier format. So this is what we thought we had. First of all, we do know just from science, studying it, that paint, the combination black and brown and white, that paint is a dominant feature. In other words, it's going to always, if somebody has a paint gene or a horse has a paint gene, it's always going to dominate. It's always going to come out. So this is what we thought we had. We thought we had a stallion that when he gave an allele, that he could either, because he's got diploid genetics, right? So he's got pairs. So he could give one of his pairs that was a dominant paint, or we thought that he also, if he would give one of the others, that it was also going to be a dominant paint. Because we were pretty sure with our mare, we knew that she had a, first of all, she had a dominant paint gene. How do we know that? Because she is a paint, so we know she at least has one dominant paint gene. But her father was actually a bay, just a brown horse with a black mane and tail. So we knew that she also had a little recessive gene in there. So this is what we thought would happen. We thought the dad would give a big paint gene and the mom would give a big paint gene. Or the dad would give a big paint gene and the mom would give a little paint, or a little solid, a little recessive. The dad would give a dominant paint, the mare would give a dominant paint, or the dad would give a dominant paint and the mare would give a recessive solid, not paint. Okay, so that's what we thought these combinations, as we put the combinations together, we would have gotten a paint horse, because big P, you actually have two big P's. Big P, so that would be a paint, because the paint, the dominant, is going to always override the recessive gene. So you'd have a paint. Here you would definitely have a paint. Here you would definitely have a paint. So that's what we thought. We thought we were going to get a paint filly or a paint colt. We thought it was going to be a paint. Now, these combinations, while they all, the phenotype of all of them is paint. The phenotype that we see is paint. The genotype is different, okay? These are homozygous paint genes and heterozygous paint genes. Homozygous means that the alleles are the same. Big P, the same. The same dominant gene came from the mom and the dad. Those are the same. They're homozygous, okay? This one is heterozygous. The dad gave a big P. The mom gave the little recessive P that got overridden. This is heterozygous. They're different. Homozygous, heterozygous. So it's really important to know if you've got a homozygous paint or a heterozygous paint. And the only way to know that is by genetic testing. So we knew we had a heterozygous paint. We knew that just because we knew her grandfather was a bay. But we thought we had a homozygous paint stallion. So we thought we had 100% chance of getting a paint offspring. Here is what we actually had. All right. So what we actually had, the mom was heterozygous paint, but the father was also heterozygous paint. Now we know. So what happened was, these were our chances. The father could have given a big P and the mom could have given a big P. Or the father could have given a big P and the mother could have given a little p. Father could have given a little p. The mother could have given a big P. Father could have given a little p. The mother could have given a little p. Okay, so in this instance, we have homozygous paint. That would have been a paint. That's 25, that's one possible offspring. In this chance, we have a heterozygous paint. So in this combination, we would have got a heterozygous paint. That's another 25% chance offspring. Down here, we have a heterozygous paint. Another 25% chance paint offspring. Oh, look, 25% chance, little p, solid, not paint. Now, there's no big P to override it. So, with just two little P's, we just get a solid, colored, little brown baby with a black mane and tail. And super, super, super cute, but not a paint. So, we had a 25% chance of getting a solid and a 75% chance, 25, 50, 75, 75% chance of getting a paint, and we hit the jackpot only in the other way. So that is how the Punnett Square works. So you can do that with pea plants if you want, but talking about is a pea plant going to be green or yellow is not quite as interesting to me as talking about horses. So that's why I use the horses, but you can use it with plants too. What color is the flowers going to be? Are the leaves going to be curled or not curled? Keep in mind, genes do work with other genes, and you can have hormones and you can have factors that turn genes on and turn genes off. So, for example, you can have hormones that actually turn on genes for curly hair or turn them off. So, there's a lot more complexity going on, but at least you know the basics of genetics that Mendel studied with the pea plants. So, maybe you can come up with a Punnett Square of your own for something that affects you, color of your eyes or whatever. So, just practice it on your own. So, have a great day. See you next video.